Zombie apocalypse.
Okay, so today's topic is the third concept of identifying the stresses of a pre-stressed concrete. So this is what we call the load balancing method, okay? So be ready to be neurorized. Okay, so ano nga ba yung concept behind to the third concept? Okay, let me present you a little description of what is the third concept, or also known as the processing to achieve load balancing or load balancing method. Actually kasi when we have a beam, let's say, let us remove first yung tinatawag nating tendon. So therefore, the beam itself has self-weight and or some additional load. So therefore, it will be the immediate load to be carried by the beam, and most likely it will be the source of deflection, or most probably the stresses to be identified within the beam. Now, as we install the tendon, so most likely it will produce some counter stress that may influence to the upward direction of the deflection, so resulting to a probable unbalanced condition. So yung unbalanced kasi na sinasabi doon is yung tinatawag nating um, counter to the gravity load that is being applied to the beam. So, there will be a point in question if gaano ba kalakas yung pag-produce ng tendon force, as of course the pre-stressing force is concerned. So, will it behave a value of deflection going up or a deflection going down? Most likely, it has something to do with compression and tension state. So, yan yung magiging influence ni load balancing method. Nagkakaroon ng unbalanced condition. So, resulting to a potential upward location, upward cambering yung tinatawag natin. Okay, suppose that we have this beam, actually si concrete beam can have different sets of what you call these tendons, most likely what is a typical used tendons is the parabolic. Notice this is parabolic. Okay, why? Kasi usually ang beam weight naman is uniformly distributed, That's always the case. Also, some loads like live load and dead load, additional, notional, or yung tinatawag nating superimpose are all distributed, Kaya usually the adaptation of the tendons are arranged like this. But in our video discussion, in one of my lectures, I'll try to discuss yung mga different setups ng tendons, kasi minsan merong mga malalakas na joint force na ikinakabit sa pre-stressed tendon, pre-stressed concrete beam. Kaya that's why nagiging dominant yung mga concentrated force. Now, if there's no case like that, then most likely makikita nyo is parabolic in tendon. It is because to resist the the downward location or the downward direction of the said loads, Okay, as illustrated here, WT represented by the sum of all gravity loads are going down, and then as you apply a simple free stressing force P, okay, so suddenly of course it will produce an upward, kasi na-define na natin dati non-deflection yan, most likely magiging ganyan. Okay, compression below, tension above, so therefore there will be a possible counter an equivalent, yung tawagin nating delta W. Okay, this one, this will be what we call the weight or the uniform load produced by the pre-stressing force. Pinagkaiba nito sa C-line method is C-line method only considers the induced compression tension force as fair value of pre-stressing force, while this kino-convert po ng beam natin into an equivalent uniform load, and it will be called as the unbalanced uniform load. Okay, so therefore there will be some potential case na mas let's say WT, okay, can be more than or equal delta W, or pwede yung WT natin potentially be less than delta W. Okay. So either way, there will be some consequence of what will happen to the beam if these two will be considered, these two conditions. Okay. Now, let us try to derive some computations. No? Yung i-derive natin ngayon for parabolic tendons only. If other than parabolic, I'll try to discuss that in one of my video lectures. What if concentrated load nga? We will try to understand how do we analyze load balancing. But for the meantime, since the fundamental or the general principle of prestressing is to consider a uniform loading, since the beam weight is distributed uniformly, at the same time all other loads like that is way applied on the slab, okay, then reaching to the beam. As well as sa slab, ano, ganun din gagawin. Ang condition kasi niya is parabolic, ano. What we are going to do is this, pass the cutting plane in the middle, and then get a particular portion, let's say this point, okay, and then try to analyze, no, that will be the figure. So therefore, if we have force P, no, P bar, that is the horizontal force H, also known as the force P prestressing. So then we try to produce an angulation, let's say a value of theta, and then we will have some components, bar P sin theta and bar P cosine theta, due to the attribute of the what we call components. And then if we try to sum up force vertical, we will have delta Py bar equals delta Wx. Okay, delta Wx natin, yung pinaka-ano natin yan, no? Yung pinaka-assume in unbalanced load. While performing EFX, then we will have Px bar that's equal to horizontal for S, and don't forget that this also the value of P, no? And then if we get tangent of theta or the slope, so that is Py bar over Px bar equals y prime. So we also know this from calculus, it is dy over dx. And then as we use the integral purpose of the equation, integral y prime, so equals to y equals, by integration, no, you will know how dy over dx naman yung y prime, then you will have this formula. Then supplying the following conditions. Okay, now note that at the lowest point, okay, we have at x, no, this x, no, which is half of it, L over 2, and then y is the set to be eccentricity, since this can be assumed as the height, or rather the eccentricity condition with the distance from the center of gravity of the beam with respect to the center of gravity of the tendons, or the CGS. Since theta is too very small, then we will accept that bar P cosine theta is also P, also known as H, kasi napakaliit lang talaga ng pinaka-angle niya with respect to the horizontal. Okay, almost tolerable. Okay, so therefore as we supply this set boundaries, then we will try to understand now this formula, delta W, or the unbalanced unit weight, or we can call unbalanced unit load as 8PE over L squared. Ginagamit lang po ito kapag ang ating formulation ng tendon is just for parabolic. Okay, other than this, it can be derived using straight line rule that I will try to demonstrate. But again, ang sinasabi ko nga is very common kasi na consideration ng ating beam is considering uniformly distributed load due to the fact of the tributary attribute of the load with respect to the application area. Okay, so that's it, ano? Ito po yung tinatawag nating load balancing method na gagawin natin. And then for comparison, that we will try to understand that the W, let's say a net value W will be always equivalent to the weight, no, is either initial or maybe final, plus the delta or the unbalanced load under initial or final. Okay, then that's it. Then we proceed to the stress review. So we will try to discuss, no, in the next video lecture is the application. So this derivation looks like a theory of structures to us, since load balancing is derived from theory of structures. Okay? Now before we end this video lecture, again for review, sign conventions again. So kapag papuntang compression, gawin nyo lang po negative, and kapag positive, are for tension. Okay? So kung ito po yung joint natin of analogy, so pagka away, so most likely, no, it will become tension. Kapag towards, will become compression. Ganun lang po tayo. Okay? For reminders. Okay, I hope you learned something from this discussion or as a principle. So let's try to take a look what if this is applied on an actual problem. Again, our very tradition, you have been neurorized, and see you in our next video lecture.